Welcome to Agents of Change, conversations with the people shaping sustainable manufacturing. This podcast is a virtual hero media production for the MANSUS platform. Hello and welcome to Agents of Change, the podcast for manufacturers building a resilient, flexible and sustainable future. I'm your host, Gemma, and today I'm joined by Jason Rolland, Senior Vice President of Materials at Carbon. Jason, welcome to the podcast.
Thank you.
Before we get into what Carbon is, who you are, and why we're here to have this conversation today, I sort of want to set the scene for the audience. We're recording this episode coming toward the end of June 2025, and so far this year, I think we can all agree that we've seen a lot of unpredictable and uncertain changes happening in the world. Mm-hmm. And a lot of those changes actually have really had major impacts in the manufacturing sector. And if we zoom in there, I think it's easy to forget that kind of chaos can cause real problems for manufacturers, just even in terms of sustaining their business today, let alone any other kind of sustainability. How do they sustain production, when supply chains are chaotic? And so that really is the anchor into our conversation today, Jason, because we're here really to talk about Carbon's approach to that more flexible, resilient manufacturing production. And so if you can start really just by giving us an overview about Carbon to set the scene.
Sure. So Carbon, we are about 12 to 13 years into the game here. And really, we've stuck true to our mission from the beginning. We have always had the mission of how do you take additive manufacturing and make it a true production technology, a true manufacturing technology, to get it out of the world of prototyping and into the world of making real products. And in order to do that, we've had to really go deep into the hardware, the software, and the material science and tying it all together, in addition to product design and working hand in hand with our customers to do this. So that's really who we are. And I think we've done that quite successfully in a number of segments and are continuing to grow our business and expand into new areas.
Yeah, and I think the first time I met some of the Carbon team was at Formnext. And I think just touching on what you said about real world products, that really is a defining thing about your exhibition stand, that we're not looking at prototypes or concepts, we're looking at products that are out there in the world. So from your perspective, with that anchoring of what we're here to talk about today, the challenges really that manufacturers face, what do you see them being, and really where do you see Carbon fitting in to help them solve those problems?
Yeah, well, there's a lot of ways to approach that question. I think, you mentioned the global trade environment, and I think there are two main aspects there where additive technology and Carbon's particular approach to additive technology can be useful. The first is just flexibility. So with a traditional injection molding system or other traditional ways of manufacturing parts, once you have your design locked and your tooling made and your factory up and running, you're pretty locked into that. And that works really well if you're trying to make millions or tens of millions of something. But if you want to live in a world where you have to adapt and maybe change your products and have a more flexible manufacturing line, you really need to go on to a different platform. And this is where the digital technologies like Carbon's additive platform can really be helpful. So the first I would say is just the flexibility in terms of what you can make and how you can make it, and being able to adapt to daily change out in the world. The second area is, again, the ability to react. It's this idea of local production, this idea of localized production. So if you have a tariff situation where the tariffs are changing, on a chaotic daily basis, and you don't know maybe where I can ship what and what I'm going to have to pay, it helps a great deal to be able to have, this vision for smaller, adaptable factories within, locally. And so if you want to produce parts in China for China, you can do that. If you want to produce parts in the US for the US, it's a flexible, dynamic manufacturing platform that can maybe keep up with some of this chaos that's going on out in the world. Now, we also have our own supply chains. We have to get resin to different places, and we've had to, rethink our own business. But I think at the core, having flexibility in your system is really key here.
Yeah, definitely. And I think that's something that we're starting to see more and more in the additive space. People honing into that message that flexibility, that local production is a real asset.
Hmm.
And I do also think I was speaking with someone recently, I can't think who it was, and they were talking about the concept of manufacturing tens of thousands of parts and then the cost of storing all those parts,
Right.
shipping all those parts. So actually, then you start to see other wider cost implications associated with that more localized production, I guess.
Yeah, that's this idea of the digital cloud, that you can keep your inventory in the cloud as a digital space, digital files rather than physical parts, because you can keep up with demand in this way. You again have this new approach that allows you to be more flexible and dynamic.
Yeah. Can you walk us through? I think it's always helpful, in the same way that you guys have real world products on the show floor.
Hmm.
I think it's helpful to walk through some real world examples of products or partnerships, really where carbon's helped to improve performance, supply chain, resilience, sustainability. How are you approaching that with your partners?
Yeah, so on the performance side, this is really essential, and what I always say is that when we first started out, it was sort of the peak of 3D printing hype, and there was just a cool factor to having a 3D printed part, and it was exciting, and there's this new technology, and even if it didn't provide a benefit, there was something exciting about it. And those days are past us. And now we're at the point where you have to have a performance advantage. And this is something, again, that we had in the very early stages of the company was, how do you really take this technology and take advantage of the unique aspects of what it can offer? So performance is really key. And we now are in a very different world, as I said, and engaging with companies who are looking to use this technology. How do I stand out from my competitors? How do I get that extra, performance out of my product? And so this is something we've really invested a lot of time in. The areas where I'd say we've done the best here, helmets really stand out. In American football, we've this is something we've been working on for quite a while now, 5 or 6 years, maybe longer. And here we're really solving some real problems compared to the traditional foam technologies. So what you get with these elastomeric lattice structures. So first you have lattice structures which can only be made by additive manufacturing. And so now you're in a space where we have to be using additive. The advantages that it brings, you have heat management is a really big one. This is something that we've had players wearing our helmets for many years now. They don't want to switch to anything else because it's so comfortable and can manage the heat within their helmet. And then the really interesting area is impact performance. And this is where we've been able to work very closely hand in hand with our partners and design both materials and lattice structures. And this is relatively new to be able to do this and to be able to go through these iterations so quickly. Another back to that sort of dynamic manufacturing environment, to be able to change and test and validate in such a rapid fashion is pretty new, and it's very difficult to do with other technologies. So we have software tools that can help us design the optimal lattice structures to absorb impacts. And then we have materials that have been optimized for energy absorption. We couple those two things together, and all of a sudden, now we have a helmet that is performing better than any helmet previously. And what I take a lot of pride in, the NFL puts out an independent ranking of all the commercial helmets, or the top commercial helmets, every year. And a helmet using Carbon's technology has been at the top of that list for the last 5 years. And this year in the 2025 list, we had the top 4 spots with 3 different companies, actually, all using our technology in different ways, different geometries, and that type of thing.
That's
So
awesome.
there you're really just getting maximum performance with this new technology. And then the third aspect within helmets that can really be useful in terms of performance is this ability to customize.
Mm.
And this is something that a lot of people aren't used to thinking about, because they're they maybe think that it's harder to do than it is outside of certain industries like dental. Dental does custom all day long. They're very comfortable with custom. Outside of that industry, it's sort of this new thing that people are maybe a bit scared of, and how would I do that? But it's definitely a huge advantage on anything that interfaces with your body, that to have that be custom. So in helmets, we've really stood out as, this is a higher performing technology, and therefore, sure, it might be a bit more expensive than the foams, and we're, continuing to drive costs down. But if you have that performance aspect, people are willing to pay more. This
Yeah.
has been a big lesson for us. Two other areas that I'll just highlight in terms of performance. One is in bike saddles.
Yeah,
In
before you
terms,
do, can I
oh,
ask you a
sorry,
quick? Sorry,
yeah, sure,
Jason.
sure. No, go ahead.
I just want to ask a couple of questions just about the helmet because my brain's racing with loads of questions.
Yeah, sure.
One is obviously we're talking about performance in terms of the actual helmet's performance, but then that performance also impacts the player's performance, right?
Sure.
So
Yeah.
there's a like a wider value to impacting the performance of the helmet because then you impacting the actual experience of playing the game, which I
hmm
think then probably adds more value to. It might be more expensive, but that's another reason why people are willing to go down that route. But my other question is, are most of the other helmets manufactured in relatively the same way?
You mean the helmets using foam liners?
Yeah, is that quite a similar process that other manufacturers use?
I think they all do things a bit differently. I think there's, a range of commercial foams out there, and they might all be using the same two or three different foams, and they might be assembling it different. Helmets are pretty complicated. You have the interior, the padding, which is where we focus, but there's also a lot of technology in the shell, and so everybody has a different technology and approach to doing that.
Yeah,
So it's sort of this combination of factors, but I would say that the things that are in common, yeah, everything is using foam that isn't using our technology.
yeah,
And then there's various aspects in terms of how you place the foam in, how thick it is, how it couples with the rest of the helmet, the shell material, the shell geometry, and all of that. All of that factors into, the overall ability to absorb an impact
yeah.
in a game or something.
The reason I ask is because I'm wondering what happens. You've got this product and it's this helmet and it's roughly manufactured in a very similar way using foam, and people
hmm
don't know what they don't know. They don't know that they can have lattice structure. They don't know that they can have a more heat control, a better experience for the player, all that kind
hmm
of stuff. So what's the bit where I guess this is what Carbon do, they help
hmm
companies to see the potential to improve performance of products. That's the bit where you guys come in.
Yeah, that's exactly right. And what we have found is that it's not enough to just drop a machine off and some software and some resin and just say, "Here you go make the best helmet."
Yeah,
Because the technology is so new, and a lot of people haven't even heard of a lattice structure before. So how in the world are they going to sit down and just design the best performing helmet? And so the software tools go a long way to helping with that. But also, once we have a committed customer, and we know that we want to partner together and commercialize these products, we have a team of applications engineers that will get in side by side with the customer to develop the application. And in many cases, we're not even trying to sell a printer to this customer. We're just trying to develop a product, and with the idea being that when we go to commercialize that, we have CMs, contract manufacturers in various locations who can make the actual pads,
yeah.
and that will drive printer sales and resin sales. So it's a bit of a different model, but it's something that's we recognize as necessary, so that we can get as many of these applications out into the world as possible.
Absolutely. And sorry, because I stopped you in your flow. You're about to go
No,
on
you're good.
so we talked about helmets, and then you were going to tell us about some more applications.
Yeah. So in this similar vein, again, where we've seen, there's lots of areas where I think additive manufactured parts can perform better, and I think we're just scratching the surface. But where we've really been focused the last few years is in, I would just call it sort of advanced cushioning technologies, and so, in energy management. So whether you're trying to absorb and dissipate energy in the case of a football helmet, or in some cases you're trying to return energy, as is in the case with a running sneaker, but also in a bike saddle. This is another area where we have some of the highest performing saddles that the world has seen. And if you go and read the reviews on these saddles, people absolutely love them. We have people who are really hardcore cyclists at Carbon who just say it's the most comfortable saddle I've ever ridden on. And again, that's part of this ability to very finely tune that cushioning profile. And so there's huge problems in that industry with sit bone pressure. There's pressure underneath the sit bones and long-term riding that can really lead to damages and a lot of pain. And the ability to dissipate that pressure and to manage that pressure and the heat and the humidity and all of that, similar to the helmet, but in a different way, really impacts the performance of that saddle. And as you said, also impacts the performance of the rider. So we have, many of the top, Tour de France riders are using our saddles. We have many different partnerships with a lot of different companies, but that's another area where I think it's a very clear performance win. We also have opportunities for customization within that as well. We did a product with Physique, the one-to-one saddle, where you're able to get a pressure map, and you sit down and you're able to get a pressure map and then transfer that pressure map onto a saddle, and so that it's custom made for you and it has support where you need support. And so this is a very, very new area. And I think as customers see this, it's going to start to become expected that this is now a thing that I have. And, I want a saddle custom for me.
Yeah.
And again, all of this leads to higher performance, more comfort, less injury, more time on the bike and all of that stuff. So that's another area. And then just one other area with that we're increasingly building out and very interested in is in the area of wheelchair cushions. And again, following the same theme, you have a part that where thermal management and management of moisture is very, very, not just from a comfort perspective, becomes a very serious problem. If you develop sores and skin sores, which is very common, that can be life altering. And in some cases, life threatening. And it's a very serious condition. And it's all comes down to pressure, heat, and humidity and managing all of those things. And what we found is that with lattices, you have a much more breathable and supportive technology. And then you also have this opportunities for customization there, where you have, somebody's in this cushion almost the entire day, and you want it to be as comfortable as possible, and you want to begin to try and have this be as dry as possible, and then and again manage that temperature and humidity. So this is another area where we're very, very excited about, where we're solving very real problems. And where people are certainly willing to pay more for something that's higher performance and more comfortable. So you can sort of see a theme in all three of those areas, even though they're very different. But they're all areas where we are looking to replace foam and to provide a better experience for the user and just better performance overall for the part.
So that covers sort of the performance side, Jason. What about supply chain resiliency and sustainability? Have you got some examples of that in action?
Yeah, my favorite example of the supply chain resilience actually was during COVID. And, that was a very strange time and a very uncertain time. And, like everyone else, Carbon went through a period where we had a shutdown, and we had a lot of people working from home, and a lot of people looking for things to do, and how can we help? And then we saw all these stories about shortages of swabs and of PPE, of personal protective equipment, in particular face shields. We started to look at this and say, well, hey, we have a literal pilot production line in Redwood City that we can make things. And we had been using it to make midsoles and basically run production experiments on our midsoles for Adidas. And what was amazing is we were able to repurpose a manufacturing line that was making midsoles for running sneakers, and in the matter of a few days have it making swabs for collection for diagnostic tests.
Yeah.
So that's the power of this digital platform. The factory was the same. The printers were the same. We had a different resin. We had a whole, design sprint to make a lattice swab that was able to show that it was could collect the right amount of fluid. It was biocompatible. We used a dental resin that had already been approved for mucosal contact. So we were able to move very, very quickly. And then we transferred that technology to one of our medical partners. And we ended up making about, I think, just over 1 million swabs for sample collection. So that was a really, and they were used at local hospitals down at Stanford Hospital. And the same thing with the face shields. We were able to make a very comfortable lattice cushion at the part of the shield that interfaces with your forehead.
Hmm.
And again, the same things we just talked about: heat management, cushioning, and just comfort. But I think that's my favorite example of in a matter of a week or two, we were able to take this very flexible production line and make drastically different products that were needed immediately in an emergency type of situation.
Yeah.
So I think as this technology grows, as we have more and more factories around the world, that again that's unprecedented to have that kind of flexibility. So that's my favorite example in terms of supply chain resilience.
Just coming round to sustainability, obviously
Yeah.
this podcast, we very much recognize that the world is sort of in a moment of transition right now.
Mhm.
And so the subject to sustainability isn't right now, I guess, the main buying driver for a lot of companies. But it is clearly part of our future. I don't
Mhm.
believe sustainability is going anywhere.
Mhm.
So, how then does carbon help manufacturers to do things like reduce waste, to source smarter materials, or to simplify productions in ways that both make business and environmental sense?
Yeah, no, I think you're right. I think it's in the mix, and it's certainly something that consumers demand, especially younger consumers demand that companies try that they try to do something and try to move in the right direction. And I'm a big believer in incremental progress on this topic. I think if you just demand perfection all of the time, it's really hard to do
Yeah.
anything actually. And so, we've done some things that I think are within additive have really moved the needle, but also just within, traditional product development, we're able to use new materials in different ways. So, you mentioned waste reduction. This was something that we realized early on in the production of the midsoles that we have a liquid resin technology, and that's just intrinsically messy. And how you typically deal with that is it's a lot of solvent washing
Yeah.
of parts, and that works fine. But then you have to deal with solvents, and then you have a lot of hazardous waste that you need to get rid of, and that's both expensive and also not the best thing from a sustainability standpoint. And so one theme that we found is if you can align your sustainability objectives with economic objectives, it's very easy to make progress there because you have multiple things driving it here.
Yeah.
So, in addition to, not being the best sustainable thing, it costs money to get rid of hazardous waste. And so we invented a solvent-free cleaning technology for our parts that works extremely well for lots of geometries, but especially for lattices.
Hmm.
And it's completely solvent free. It basically just it's a spinner. It's derived from industrial equipment that's used to dry lettuce, actually at a big scale
Like a salad spinner.
after washing. Yeah, pretty much like a big salad spinner. And we can load our platforms into it with parts that are wet and dripping with resin. We then spin them. The resin goes to the side and is then collected and then reused. And then the parts come out essentially dry. We then go through a baking step. So there's really no need for any solvent washing. And at scale, this saves a huge amount of hazardous waste from being created. So that's one area, and we have additional cleaning technologies that we'll be announcing this year, which are in this theme of just using a lot less solvent in order to clean the entire part.
Yeah.
So again, both from a just ease of use, a performance standpoint of the part. It's less variable if you're not doing solvent cleaning, and then just the sustainability piece that all kind of added up to this really great win here. The other area where we've really done a lot is in close to my world is in bio-based raw materials. And so there's essentially two sources for almost all the chemicals in our world. One is from petroleum, and the other is from natural sources, from bio-derived sources. And there's been a big trend in the chemical industry to try to move, some of the building blocks of of widely used polymers away from petroleum and towards more bio-derived, specifically plant-derived raw materials.
Yeah.
And why that's important is it's a much lower carbon footprint. And so if you can essentially get your carbon from CO2 and sunshine and water in order to make a plant, and then take that plant and convert that carbon into sugars, which are then converted into building blocks for, in our case, polyurethanes.
Hmm.
Now you have something that where the resin itself has a much lower carbon footprint than if you had derived it from byproducts of petroleum.
Yeah.
And so again, this is what I mean by incremental progress. This is a step in the right direction.
Yeah.
And so we've embraced this. And actually, we found a performance benefit in the case of the bio-derived raw materials. And this is something that went into the product that we did with Adidas, the 4D Forward,
Yeah.
and our products, EPU 46 and EPU 44, and several others use these bio-derived building blocks for polyurethanes. And so this is another area that I'm excited to see growing out in the industry. And again, it's a nice step in the right direction.
Absolutely. And I've used this phrase before on the podcast, but it's a phrase that we use at home we've got two young children, and we always say practice makes progress.
Mhm.
And that really is a big part of what we want to do with MANSUS. It's very, very easy to be highbrow about about anything really, but certainly about sustainability. It's very easy to point out all the problems. It's actually really hard to think, but where do we start?
Yeah.
And I think we have to be realistic that we have to start somewhere. And isn't it better for the world if everybody's putting that first foot on the path and
Yeah.
then, growing that incrementally, as you say? So I totally agree with that approach. Just thinking about those biomaterials and, knowing that there's a performance benefit to that. There must be a degree of consultancy taking place here then that, if I think about the challenges manufacturers are facing, they're just trying to keep their ship floating. To have the knowledge, the expertise, and all of the requirements needed to know about everything else. So I guess I'm wanting to know a bit more about how Carbon approaches that co-development, because I think it's a really interesting business model. And I think it's an important business model, not just for the AM industry, but actually for manufacturing when we think about resilient manufacturing. I think that is very much important, that co-development part.
Yeah, absolutely. And this is, again, it has been a big change in our business model over the last 2 to 3 years. There are some businesses areas where they understand additive. And the one I'll always point to is in the dental industry.
Yeah.
That's an industry that has grown with the additive industry and out of necessity, because again, every part that you print for a dental customer is custom. It's all N of one. And so it's an industry that has been, drawing the technology out of companies like Carbon to make us better. So they're very comfortable with the additive workflow. And there you can be successful with a traditional business model, the traditional sales business model of moving printers and resin.
Yeah.
But outside of that, it's so new. And, we find customers all the time. I was just with one last week where they said, this is the biggest breakthrough to happen in our industry. This is with a wheelchair cushion company. Biggest breakthrough to happen in our industry in decades. I have no idea where to get started. It's like you look at these complicated lattice structures and you go, I have no idea how to make that. Can you help me? Can you work with me? And this is where we've found success, that to make the technology approachable. And also immediately, as soon as the customer realizes you're not trying to sell them as many printers as you can, there's a relaxation where they're not on the defensive anymore of, okay, this person's trying to sell me something, I gotta figure this out, do I really need this? It's okay, what problems do you have with your products right now, and can we work together to solve them, and is there a solution within our technology that can make it better? And so that's a very different conversation from a traditional sales pitch on how to sell a printer and drop it off. Second thing is that all additive technologies have pre-processing and post-processing, and it's complicated, and Carbon's included. And so that also this is not a magic box that you drop off and you load your file and push a button and out comes your part. No additive technology is like that. Maybe we'll get there someday, but right now it requires a lot of steps, a lot of customer education, and a lot of partnership with the customer. So again, our model has been, let's keep all that work to contract manufacturers and small additive businesses that are really good at it at that part, and we'll work with you on the part design. And
Yes.
so again, there's a level of commitment that needs to be there because we have a small team and we can't explore every idea out there in the world. This is probably one of our biggest challenges, is there's just an endless amount of opportunities and different things to work on.
Yeah.
So we need to have a funnel. We need to prioritize. We need to, be with customers who, if we're going to spend a year with you designing a part, we have to know that that's going to go to production if we're successful and that we're all going to, do business together. But so this has been the approach we've been doing. We have a very large and capable applications engineering team, and then we have people who are sort of guiding the business development. And you have to think about all kinds of aspects of things, from part costs to regulations that the parts might need to fit into and work with, sustainability. All these things have to be factored in. So there's a lot to figure out.
Yeah.
But we've just found this to be a tremendously successful model in terms of getting these applications out there. And once you do it once, then people start to see, either, it's their competitor's product is, oh, wow, that's cool, I have to have that now. Or maybe they see something in a different industry that then inspires and says, oh, okay, that the same problems they're having over there in bike saddles, I have those problems in wheelchair cushions.
Yeah.
And this is really huge for me. And so, this is been the way of operating for us for the past couple of years, and it's been really successful and refreshing change, actually, in terms of how to do this.
Yeah, I can relate. I used to work for a design automation. So I used to work for a technology company and we sold design automation software. And my role was business development. And I used to work very, very closely with our applications engineers because ultimately the way we saw it, yes, we could sell more software. And if we just went out selling lots of software and not looking after that customer and actually making sure that software is successful, it's a business change at the end of the day. You're literally changing the way your design team functions, production happens. If we don't not handhold, but support and empower those customers to make the most of that technology, we're never going to get them to do subs renewal. We're never going to sell more technology to them. So I always think about it as, like you've said, your aim isn't to just sell more printers, but I always knew we would sell more technology, we would sell more software if they had a successful project, because at the point that they're using design automation software to really make an impact on their bottom line, then they start to think, oh, what else can we do with this? And that's then where the growth comes from. So I totally agree with you. And it becomes then about really, really good account management at the end of the day.
Yeah, absolutely. And it's not to say that we're going to continue to try and make the tools and the technology easier and easier to use so that, someday, maybe with coupling with all the AI stuff that's happening, it will be easier and you will have something that is essentially a push button type of technology. But we aren't there yet. And right now, this is what we found is required to really develop these applications and get them out into the world.
Yeah, lovely. So I think my last question for you really is connected to that, which is about that investment. Manufacturing leaders are looking to innovate, but at the same time, they do need to manage risk. So what advice would you offer about when and also how to explore new technologies like yours?
Yeah, I mean, the first piece of advice would be to just call us and talk to us about it. We have a pretty good sense for what will work and what won't. We have these conversations all the time. Other things that I would just advise people: don't assume that, I guess, a couple of things. Don't assume that customization isn't possible in your industry. There's been, like, as I said, a lot of progress in that space, and a lot of people aren't thinking about it, or they're thinking that it's harder than it is. And the other piece is, don't assume that additive technologies like carbons can't hit your cost targets. This is something we run into all the time is, I thought about it, but I just figured it was too expensive. Let's figure that out together, because you might be surprised. And in many cases we have, driven the resins and the technology to high enough volumes that we do start to enjoy some of those volume pricing types of trade-offs that we're able to extend to other industries. So we've spent a huge amount of work on making the cost per part as low as possible for these high performing parts. And also, again, I can't reiterate enough just that where can we maximize performance? That this can't just be a let's 3D print. Or we meet a lot of people in like big companies that will say, "Well, I have a mandate from my boss to find something to do with additive manufacturing."
Yeah.
Okay, and that's fine. Maybe that's a good place to start. But we don't want to end up just saying, "Look, I 3D printed this part because I wanted to." It's well, what advantages of 3D printing did you use to get a better performing part? That's where we get excited, and that type of thing.
Absolutely, because you wouldn't do that with any other type of technology,
Right.
right?
Yeah,
So
exactly. Yeah.
this is just a tool, like any manufacturing tool. It's got things it can do, it's got things it can't do, and it's about finding the fit. One of the things we say at Virtual Hero Media, Jason, is that AM has spent decades looking for problems to solve. It needs
Yeah.
to stop doing that, and it needs to
Yeah.
start talking about the problems it can and is solving.
That's right.
It's
That's
quite
right.
simple, really.
Yeah, I completely agree. And in that vein, I think I would also advise people, don't be afraid just because it's not your exact material that you've been using in your product for decades. Is, well, I use this polyurethane foam. Okay, well, we have a polyurethane elastomer lattice. It's different. It's a different chemistry, but we can likely match or exceed the performance of what you're using in your foam. So a lot of times people get, "Oh man, I've been using this material for a long time and change is scary. And what is this new stuff? This is different. This is weird." Let us work with you on that. Let us, work with you on your validation and compare it to your foam and see how things go.
Yeah. Yeah. Change is scary, but informed
Mm.
change is pragmatic, right?
Right.
And that's what I really gather from Carbon, that the difference here is that you're talking about informing your partners so that they can make robust, future proof decisions.
Yeah, that's right.
Jason, it's been absolutely brilliant to chat with you. Thanks for coming on the podcast.
Yeah, thank you. This is fun.
Thank you very much. Take care.
All right. Thanks, Gemma. Bye.
Bye. Thanks for listening to Agents of Change, a Virtual Hero Media production for the MANSUS platform. You can explore more at mansus.co, subscribe to our YouTube channel to stay up to date with every episode, and follow us on LinkedIn to join the conversation.